welcome back to our channel. Today's another episode of Chem You Solve It? Today's contestant is Miss Shurie Yoshikawa. She's an aspiring doctor, which means she needs to have a sufficient knowledge in chemistry. Are you determined to win?
Yes, I am, and I'll be sure to answer the questions as best as I can.
If that's the case, let's scan through the mechanics of the game. You are given 10 seconds for conceptual questions and 30 seconds for questions that require computations. Afterwards, our scientist here today will provide the answer for the conceptual questions through performing the experiment, and our teacher present now will show how to solve for the answers to questions that require calculations. Are you ready?
Yes, I am ready and prepared.
Given this setup with a cup filled with water and you placing the straw inside, answer the following questions. What happens when you sip the water until it reaches near the end of the straw, taking it out, then placing your index finger over the top of the straw? A. Water will flow down the straw and back to the cup. B. Water will remain in the straw. And C. Water will not enter the straw. What is the correct answer?
B. The water will remain in the straw.
That's correct! Let's see how our scientist will demonstrate the experiment.
Fill a plastic cup with water and place a straw in the cup and sip until the water reaches near the end of the straw. Take the straw out of the cup and place your index finger over the top of the straw. Can you see what happens? How can this be? When you suck the air out of the straw, you decrease the pressure inside the straw, allowing the higher pressure on the rest of the surface to push the water up the straw and into your mouth. The relationship between volume and pressure is illustrated in Boyle's law.
That demonstration was splendid! We say thanks to our scientist. Our teacher will show how to solve this problem.
Alright, to solve the correct answer, let us solve it manually. Let's read the problem again. A neon sample occupies 4 liters at a pressure of 5 times 10 raised to 4 pascals and a temperature of 273 Kelvin. We are tasked to calculate the volume of the sample at standard conditions of temperature and pressure. Since 5 times 10 raised to 4 pascals is our initial pressure, we shall convert STP, which is 1 atm, into pascals, which is equal to 101,325 pascals. And since temperature does not change, this is an application of the Boyle's law, or V2, which is given by P1 V1 over P2. We then substitute the values. With the use of a calculator, we will get an answer of 1.97 liters. Rounding off to one significant figure, our final answer is 2
Thank you for that very simple and helpful explanation, teacher. Let's change the setup a bit. Now, you fill the water up to the brim and secure an index card on the lip of the cup. What happens if you turn the cup sideways and then turn the cup upside down, then letting go of the index card carefully? A. The water won't escape. B. The water will seep through the index card. And C. The water will pass through the small holes between the brim of the cup and the index card.
A. The water won't escape.
Yes, that's correct! How our scientist will demonstrate the experiment.
When you first turn the cup upside down, the pressure of the air inside the cup and the air pressure outside the cup are equal. If you look closely, however, you'll notice that just a little water leaks out between the card and the cup. This happens because the force of gravity naturally pulls down on the water. When some of the water escapes, this causes the volume of air to increase slightly. Even though the amount of air above the water stays the same, the volume occupied by the air is now greater and the air pressure inside the cup decreases. The pressure of the air outside the cup is now greater than the pressure inside the cup, and the card stays in place.
That demonstration was splendid! We say thanks to our scientist. And the question for the viewers, What would happen if a candle was put in a plate with water and was covered with a glass cup? Did you get it? The answer is the water will rise up. Here is an explanation why.
Set the candle at the center of the plate. Use a bottle cap as base to support the candle. Light the candle with a lighter or a match. Then, carefully pour water on the plate until the whole base of it is with water, enough to reach the candle at 1 centimeter or more. After which, place a glass over the candle and observe what happens. What happens to the candle and the water level? The flame heats the air inside a container and this hot air expands quickly. When the flame fades and goes out, the air in the container cools and the cooler air contracts or takes up less space. That contraction creates a weak vacuum or lower pressure in the container. The higher pressure is outside the container, pressing down on the water in the dish. The outside air pushes water into the container until the pressure is equalized inside and outside the container. The water stops rising when that pressure equalization is reached.
Our teacher will show how to solve this problem.
This is an application of the combined gas law, for there are no values or quantities that are constant. So the formula for the combined gas law is given by P1 V1 over C1 is equal to P2 V2 over C2. T2, when isolated, is found by multiplying T1 P2 V2 over P1 V1. Substituting the values, with the use of a calculator, we get the value of 32.26 Kelvin. And rounding off to one significant figure.
Thank you for that very simple and helpful explanation, teacher.
Thank you, Miss Shurie, for participating in today's game. Stay tuned for the next episodes of Chem You Solve It?